Hello Year 9. Today we are going to look at a chemistry topic, and the title of today's topic is Giant Ionic Lattices. This is a form of substance or a type of substance with very particular features, but we need to understand how they're made, and therefore we can then go forward and ask those questions as to how it has those particular features. So to begin with, though, we're just going to answer questions about how giant ionic lattices are made and why many of these materials are hard crystals. So if we look in our booklet, when we carry out a chemical reaction, we do not just use one or two atoms. So often we think when we look at a chemical reaction, and it's particularly a chemical equation, it's just literally one molecule plus two molecules react together to produce one or two molecules of the products. No, it doesn't work like that. You use billions when you carry out a chemical reaction. And when metals and non-metals react together, we've already found out they form ions. Now those ions are charged particles. So if an atom has lost one or more electrons, they become positively charged. And then if another has gained one or more electrons, it becomes negatively charged. Okay, so that was a story we had in the last lesson. However, let's make this a little bit simpler. I'm going to get rid of those symbols. We can consider them to be like this. Now, here we have a positive charge and a negative charge. So what happens when a positive charge and a negative charge come close together? Hopefully the key word you're looking for, and it's coming to your brain right now, they attract. So opposite charges attract each other. Okay, so they will exert a force equal but in opposite directions, and then just like a north and a south pole of a magnet, they will eventually interact like this. Now remember, there are billions and billions of atoms and therefore ions in a reaction. So we'll end up with all of this going on, plus, minus, positive, negative, over and over and over again, not just in this one dimension, but in two dimensions, over and over again, these what we call electrostatic forces holding the whole thing together. And if we can imagine another row behind, we've got other things going on. We have a negative, a positive behind here, negative, positive, all of this in three dimensions. So we'll form crystals, hard crystals held together by electrostatic forces. And this kind of structure is called a giant ionic lattice. And we need to describe in detail how these are made. And we're going to use ideas from the previous lesson, then just use our new ideas about electrostatic charges and forces to finish off as answering a question. If we look at the exam question halfway down, it simply says, for 4 marks, describe the structure and bonding of sodium chloride. And in brackets there's a number 4 marks. Right, we are going to have to look at what we know about sodium and chlorine. Let's take it all the way back and then take it forward to answering this question. What do we know about sodium? If we look at sodium in our periodic table, we are going to find this. And if we look for chlorine, not chloride, chlorine, we will see this. Okay. And this is all the information we have from the periodic table. And again, so that you can use this. If you know what it means, you can use this. Sodium is also in group 1. Chlorine is in group 7. Why? Well, we can draw the electron structure. Usually I start with a dot in the middle to show the nucleus. It has 11 protons, and therefore the atom will have 11 electrons. And I draw them as crosses in these things that we call energy levels or shells. So far, got 1, 2 in the first, 8 more, gives us 10, and finally 1 on the outside. I'm going to put that over there. This is a group 1 element, we can tell, because it's got 1 electron in the outer shell. Let's look at chlorine. Again, a dot for the nucleus, just as a point of reference. This one has 17 protons, and therefore, because every atom is neutral, 17 electrons. Now I'm going to, just to help me, draw circles for my electrons. In reality, electron is an electron. They are all the same, but it just helps me to understand what's happening. Okay, this one has 3 shells, it's in period 3, and it has 7 on this outer shell. Again, this is just me thinking aloud. I haven't even got to answering the question yet, but this is just going back to first principles to help me work out where to go. Looking at this, sodium does not have a full outer shell. The easiest way to get a full outer shell is to lose just 1 electron, this one in its outer shell. This one has not got a full outer shell. The easiest way for it to become full is to gain an electron. So this electron is going to go to the chlorine atom. Okay, now I'm going to try to rub that out without rubbing out everything. Carefully around. So we don't need the outer shell anymore, it's not there. The outer shell is now the second shell with some electrons in it. Now these things are no longer atoms. We now call them ions because they have now got charge. An atom has no overall charge, an ion has some charge. To show it's an ion, I'm going to draw square brackets. This has lost a negative electron. That makes it a positive ion. Losing a negative particle, an electron, makes the remainder positive. This electron has transferred across to the chlorine, which is now an ion. Oops. So it's gained a negative electron and now has a negative charge. So this is now sodium ion and chloride ion, which we write like this. We're getting there. We're getting there. What we now have is an idea that the sodium ions are positive and chloride ions are negative. So in our heads we can picture these billions and billions of positive sodium ions now being attracted to the negative chloride ions. And as I drew already, positive, negative, positive, negative, strong electrostatic attractive forces forming these what we call ionic bonds over and over again, really strong for billions and billions, and also in 3 dimensions. So I can just draw 1 row here behind in 3 dimensions going off into the distance. Okay, all the way around in 3 dimensions, over and over again, and I could fill the rest in, but I won't. Right, so what's the answer? Describe the structure and bonding of sodium chloride. Here's our picture. We have sodium ions and chloride ions, the positive, negative ions. So we can say sodium chloride is a giant ionic lattice So that's our description of what it is. So what does it mean? Made of alternating positive ions. Let's add some more detail. Positive sodium ions and negative chloride ions. These ions have opposite charge, opposite charges, and so are held by electrostatic forces. Okay. So we've said what it is, 1 mark. We've explained why, and not only that, we've said what these ions' charges are. And then we've identified the fact that they are opposite, and therefore they produce these electrostatic forces. So we've made 4 distinct points there. If this is 1, 2, 3, and 4. 4 marks for our GCSE chemistry answer.